Today we'll be solving question number 5 from the CAT 2018 slot 2 question paper. So in this question it has been said that if a and b are integers such that twice of x square minus ax plus 2 is greater than 0 and x square minus bx plus 8 is greater than equal to 0 for all real numbers x, in that case we need to find out the largest possible value of twice a minus 6b. So now it has been given, if we consider the first equation, it has been given, not equation rather, in equation, it has been given that twice of x square minus ax plus 2 is greater than 0. So in this case, the discriminant of this expression will be less than 0. So this will give us, discriminant of this equation will be given by a square minus 16 will be less than 0, and this will give us that the value of a will lie in between. Basically this can be broken down as a minus 4 into a plus 4, and the entire structure will be less than equal to 0. So if we take the number line and if we take minus 4 over here and 4 over here and then plus minus and plus, so this gives us that a will lie in between minus 4 and 4. So minus 4 will be less than a and a will be less than 4. So this is the first condition. And the second condition, if we try to look forward, will be we have been given that x square minus of bx plus 8 is greater than equal to 0. So the discriminant in this case will be less than equal to 0 and not just less than, since there is a equal to sign over here, so this will be less than equal to 0. So therefore this gives us that b square minus 32 will be less than equal to 0, and ultimately the range of a will be in between minus 4 root 2 will be less than equal to b, and this will be less than equal to 4 of root 2. Now it has been mentioned that b is an integer. So since b is an integer, the range of b will thereby lie in between minus 5 and plus 5. And we need to find out the maximum possible value of twice a minus 6b. For this, we have to maximize twice a and minimize minus of 6b, or rather just 6b. So if that happens, twice of a will be maximum. Since a is also an integer, the maximum possible value of a will be 3. So this will be 2 into 3, that is the value of a that we have taken over here, will be equal to 3. And since we have to maximize b, so b 6b we have to minimize, so 6b will be minimum when b is equal to minus of 5. So this will be, b will be equal to minus 5, and the entire structure upon doing the necessary operation, 2 into 3 will be 6, 6 minus 30, 6 plus 30 will be equal to 36. So the largest possible value of twice a minus 6b will be equal to 36, and which is the correct answer over here. Now let's move on to the next question. Now we are doing question number 6. So in question number 6 it has been said that if a is equal to the set 6 to the power twice n minus 35n minus 1, where n is basically can take an integral value from 1 to 1, 2, 3, and it will go on. And if b is equal to 35 into n minus 1, where n goes from 1, 2, 3 up till all integers, then which of the following is true? The options that have been given are that every member of b is in a, and then at least one member of a is not in b, and then it has been given the third option that neither every member of a is in b nor every member of b is in a, and then it has been said that every member of a is in b but at least one member of b is not in a. So let's start off with the expression for the set a. Now in set a it has been given that 6 to the power twice n minus 35n minus 1. So this can be written as 36n minus 35n minus 1. Now this 1 that we have taken over here, this can be written as 1 to the power n. So we can write it down as 36 to the power n minus 1 to the power n minus 35 n. Now the point that the idea that we'll try to incorporate over here is that we know that a to the power n minus b to the power n is a multiple of a minus b. So here we have 36 to the power n minus 1 to the power n. So this definitely will be a multiple thereby of. So this 36 to the power n minus 1 to the power n will be a multiple of 36 minus 1, which will be basically equal to 35. So this entire structure that we have taken over here, 36 to the power n minus 1 to the power n, we could have written it as 35 into suppose some multiple k minus 35n. So if we take 35 common, so this will be equal to k minus n. Okay, so this is what the entire structure of A comes down to, and we have already been given that B is basically equal to 35 into n minus 1, where n goes from 1 to 3 and takes all the integral values. So from this you can definitely say that basically B contains all the multiples of 35, and the set A also contains multiples of 35, but not all of them. So therefore we can say that every member which is in the set A is ultimately in the set B, but there are some elements in the set B which is not in the set A. So therefore option 4, that has been the statement which is given by option 4, which basically tells that every member of A is in B, but there is at least one member of B which is not in A. This statement fully describes the given condition over here. So option 4, the statement 4 over here is the correct option.